So my name is Muzic. I'm a researcher at the Institute of Astrophysics and Space Sciences in the University of Lisbon.
What is the best thing and the worst thing about your job?
The best thing, I think there are few good things. I think the one is a flexibility and the creativity. So one always tries to find some answers, but then once you get closer to an answer, you open another question. So I have a feeling it's something that you always have something to do. This is an interesting thing. And another thing that I really like is the flexibility. So I can do my work on the pace that I want and whenever I want. And so this, I don't know, makes me feel not so pressed by external factors, maybe.
And are you able to balance your work life with your personal life?
I think I am. I think this is a very important question because I have a feeling many astronomers, they work really a lot. And in general, maybe this is a part of when we talk about the flexibility. Our job is very flexible, but then at the end we are the ones who put our own limits, and sometimes we maybe make a lot of pressure on ourselves. And so I find it really important to have some kind of hobbies and other different activities that one can do outside of astronomy. So I think I am trying to do my best, but sometimes it's not the easiest thing to do, but I think it's something that is really important to consider. What would be the worst thing? I think the worst thing is instability. So there is actually one really good thing is that we as astronomers get to travel a lot, and not only for the conferences, but we also have opportunities to live in different countries, and this is something that I like. But at the end, the system is such that it's very difficult to find a stable and permanent position. So at the end, we end up moving a lot, sometimes also because of this instability. So I think instability is the main problem in science in general.
And what's your topic of research, and how would you explain it to a kid in elementary school?
So my topic of research is star formation, and more specifically formation of brown dwarfs. So how would I explain it to a kid? So I would start by explaining the differences between stars and planets. So stars are these gigantic balls of gas that shine, right? So we see the sun shining every day, and so this is because stars produce energy in their centers. On the other hand, one has planets like our Earth or Jupiter or Saturn, so they have probably heard of some of those. And these are objects that orbit stars, so all these planets that I mentioned, they orbit our sun, but they don't shine, they don't have their own source of energy, so the light that we see from them is just a reflection of the solar light. In principle, study how these two types of form, and mainly stars, and also I study objects that are somewhere in between stars and planets that are called brown dwarfs, and they are not neither stars because they don't have their own source of energy, but they are not planets because they are too big and they also they don't orbit stars.
And how would you explain it instead to a student of the physics bachelor?
So I would explain how stars form. So stars form by a gravitational collapse of molecular clouds. In this process, so in the process of gravitational collapse, the cloud is becoming denser and hotter and hotter. And once the temperature reaches a temperature for hydrogen fusion, the star will start having its own energy source. However, if the mass of this cloud is initially not sufficient, then the object will never arrive to the point of fusing hydrogen in their centers. So these objects will shine, and we see them. They're called brown dwarfs, and we see them because they gain energy by gravitational collapse, but after some time they will never reach the sufficient temperature to start the fusion, so that means they will not have their own energy source, and with time they're going to cool off and become fainter and fainter and colder.
If you enjoyed the video, like and subscribe.